So good morning, everyone. I'm Tristan Salles from the University of Sydney, and I will be presenting a quick overview of Badlands capability. Badlands being a landscape evolution / stratigraphic forward model that I developed over the last 5 years to look at large scale, regional to continental scale, and over geological time frame surface evolution. So this presentation is actually pre-recorded as I'm on leave at the moment, but you will see several live talks during the BGH showcase. So I'm sure you will get some good understanding and good overview of the code capability. But feel free to contact me via my UCID email address if you need more information. So as you've already seen in previous talks, the tool has been developed in part through the Bayesian Genesis Hub funding in collaboration with our partners from academia and industry. As all of the other BGH softwares, Badlands is open source and has been initially used as an independent tool to understand source-to-sink system in different geological settings. So one of the main strengths of Badlands is in its ability to use information from other software, such as BGH ones, like Gplate and Underworld, and use them as input for running complex simulations. As an example, over the past 2 years, and in collaboration with our partner Equinor, Chevron, and OilSearch, we have designed several workflows to use plate reconstruction from Gplate as backward-forward constraint for Badlands, and apply this approach to look, for instance, at the reconstruction of the sedimentation patterns along the Norway margin, or more recently, the evolution of the Nile Delta over the last 40 million years. So while the communication between Gplate and Badland is a one-way coupling, which is represented by this black arrow on the left here, the way Badlands and Underworld communicate is a two-way, let's say, loosely coupled approach that was made possible thanks to the UWGO package developed by Romain Beuchet. So it allows to couple thermomechanical geodynamic models with surface processes. And more importantly, it allows to evaluate feedback mechanisms between the surface and the lithosphere. So before diving into Badlands capability, I just wanted to quickly present some of the open source codes that the Earth Code Lab group has been developing and maintaining over the years. Most of them focus on sediment transport at various timescales, such as Badlands and Escape, but we also started to look at global scale models and global scale source to sink code with our new tool, which is called Gospel. So we also have an expertise in designing models for looking at ocean circulation, wave modeling, and coral growth. And some of these open source tools are better suited for teaching, and all are Python tools coming with pre and post-processing Jupyter notebooks to help first-time user to familiarize with different libraries. So Badland, to some extent, combine part of this algorithm or algorithms which have been implemented in these other tools. So for instance, we use the carbonate modeling and longshore drift sediment transport that are inside PyReef core and the Ascidian model to estimate wave-induced sediment transport and reef growth in Badlands. Also, the same goes for the priority flood algorithm in Philip, which is used to evaluate depression and pit in the aerial domain and estimate the maximum volume of under-rig basins in Badlands. So in terms of capabilities, initially for the Bayesian Genesis Hub project, Badlands role was to simulate the transport of sediments from upstream catchment to downstream basin, and allowing the redistribution of sediment material over the surface. So for this to happen, I designed the landscape evolution model, and all landscape evolution models require an initial surface that can be obtained, for example, from paleo elevation models, but can also be created by the user with an idea in mind that you want to test. And I really want to point out that Badlands is a way to investigate your geological ideas and test several of your hypotheses or concepts using a physically sound tool. Okay, and I guess it's really should be used in this way. So for the aerial domain, the sediment transport is accounted for using two mechanisms in Badlands. The first one being hill slope transport, also referred to as creep law, which depend on gravity or slope and can be simulated either via a nonlinear or linear diffusion law. So the second one is the fluvial transport, which require obviously to account for different type of rainfall or precipitation regime, which might change over space and time. In Badlands, the user can choose either to export the paleo precipitation data from paleoclimate model or paleo datasets, and if they are available, but can also choose to use the orographic rain option, which basically is going to account for the change in topography to distribute the rainfall over time. As the rain will start to drop, they will start to form small rivers that will become larger and larger as they flow downstream, and these rivers will start eroding and transporting sediments. So in Badlands, a stream power law approach, which basically scale river incision to the drainage area and the slope is used. So this approach is quite simple, but is often used in landscape evolution model as it shows really good agreements with field measurements, especially when looking at long-term and large-scale evolution. So the stream power incision laws family actually comes in different flavors with formulation which describe different erosional behaviors, ranging from a detachment limited, where governed by basically the resistance to erosion, to transport limited, governed by the flow capacity to transport sediment which are already available on the bed. So in Badlands, the user can choose between 6 different formulations. Once the sediment have been eroded and transported by rivers, they can either finish their journey in depressions or internally drained basin, or being transported to the marine environment. In the simplest case, sediment will start to be deposited and form deltaic system in the ocean. Uh, Two options exist to transport sediment in the ocean. Either the Badlands wave module is turned on and will trigger a longshore drift that will transport the sediment above the wave base, or the underwater gravity flows module is on, and turbidity currents could be triggered if the river sediment concentration entering the ocean is above a prescribed threshold. So in addition, one can also choose to turn on the reef module and to simulate carbonate platform evolution. And the carbonate platform in Badlands will depend on three factors: accommodation space, wave energy, and local sedimentation rate. Over time, due to the change in precipitation, sea level, and tectonics, it's worth mentioning that tectonics in Badlands can be both horizontal and vertical displacement. The surface is going to change, and change in erosion and deposition are going to be recorded. So as sediments start to accumulate in the marine environment or inland, Badlands saves and tracks the stratal architecture history. So the user can choose to account for compaction using a porosity depth relationship, or and also can look at isostatic responses due to flexural loading using an external library which is called GFlex, which was developed by Andy Wickert. So Badlands documentation can be found at badlands.readthedoc.io, and it's basically the go-to place if you want to start using the code. So it contains all the information needed to install the tools, also information about the simulated processes, the input file description, and also some examples that are also shipped with the tool itself. Over the years, we have been developing many post and pre-processing scripts to ease basically the creation, visualization, but also integration of Badlands input and outputs. And most of these scripts has been packaged in what we call the Badlands Companion. And thanks to the user community, these processing workflows have been growing over the years, and we made them available as soon as we can. In addition to the GitHub repository, where you can find the source code, a user can access what a Badlands Slack channel, where our community can ask technical questions, and as well as post some comments, issues, and request some potential future developments. Sorry. So over the years, we have been investigating many research questions related to geomorphology, stratigraphy, tectonic and surface processes, but also the interaction between submarine canyons and carbonates. And more recently, we've been starting to look at how a mountain range might affect species richness using Badlands. I guess you will have over the course of the BGH workshop an overview of some of the cool research project investigated with Badlands. Talking about this nice research project, I think it's worth acknowledging the fantastic work that have been done over the last 5 years by postgraduate students from honors to PhD students. At the University of Sydney only, we had 11 honors and master students who completed their degree using Badlands and 4 PhD students. All of this would not have been possible without the supervision of world-class research associates who have been dedicated over the years, from Gilles Brocard to Sarah Moron, Sabine Zairovic, and Claire Mallard. The group has published around 22 papers using Badlands since 2016, and we've been traveling over the world, attending more than 40 international conferences and workshops. Badlands, as it has matured over the years, has seen its number of users increasing, with more than 35% of the published paper last year using Badlands have been published by authors from research outside of the Basin Genesis Hub and from all over the world, mainly from US and China. I guess it's also worth mentioning that Badlands is now part of 3 new ARC projects, 2 ARC linkage, one led by UNSW and one led by UWA, and an ARC training center led by the University of Sydney. So to conclude, I want to say that Badlands is a community-driven open source software that comes with a suite of workflows, allowing you to test different scenarios of surface evolution over regional to continental scale and over geological time frame. It is initially designed to model sedimentary system through space and time and test basically the response to the stratigraphic record to climatic, tectonic, and sea level condition. And really it allows geoscientists to test the relative roles of this forcing in changing not only the surface expression of the Earth, but also the sediment routing and associated stratigraphy. The tool has evolved over the years and is now applied to cross-disciplinary studies, looking, for example, at the role of landscape and biodiversity, but also the interaction between inland region, offshore marine sedimentation, and accounting for carbonate platform formation. So if you need more information, do not hesitate to contact me via email. I leave you here and wish you all a nice BGH workshop.